Namaste everybody. My name is Harshvardhan and welcome to my YouTube channel Chemistry with Harshvardhan. Today we are going to talk about laws of chemical combination and Dalton's atomic theory. But before moving ahead, let me tell you that this lecture is completely in English. If you are a student who want to study in Hindi plus English language or in Hindi, you can watch the lecture in Hindi plus English language that is available in my channel. Okay, so there is a complete entire course going in English plus Hindi as it is going on here. Okay, so let us start our lecture of laws of chemical combination. Okay, so in laws of chemical combination, what we basically see is the chemical compounds. Okay, they are found by elements by following some specific laws. Okay, as everywhere there are laws in school, there are some rules, some laws that every student have to follow. In the same way, the elements also follow certain laws to form compounds. But in school also there are certain exceptions sometimes, as you would have seen that sometimes some students directly go from class 1 to class 3. Okay, what they do is they give the examination of class 2 and class 3 at the same time. This is basically done because they are extraordinary students. So this is an exceptional situation. In the same way, while compounds are formed by the elements, okay, they sometimes also do not follow the regular rules, and there are certain exceptional conditions also. So we are also going to talk about those exceptional conditions in this particular video. Okay, so let us start with our laws of chemical combination. So as I have already told you that these are the set of laws which are followed by atoms of elements to form compounds. Okay, so let us write it down. Laws of chemical combination. Okay, these are the laws, these are the laws that are followed by elements while forming compounds or undergoing reactions. Okay, so you can note it down. Okay, so if you want, you can pause and note it down. Okay, now moving ahead, we are going to talk about the first law, that is law of conservation of mass. Okay, the first law is what? Law of conservation of mass. Okay, so dear students, this law was given by Antony Lavoisier. It was given by Antony Lavoisier. And what does this law say? This law says that matter can neither be created nor be destroyed. Okay, I repeat, matter can neither be created nor be destroyed. Okay, so this is very philosophical. It simply says that during a chemical reaction, neither a new matter can be created nor it can be destroyed. Okay, or particularly it is talking about the atoms. Okay, that it can neither be created nor be destroyed. Okay, now here it is very philosophical, but to use it in numericals we need to interpret it. So its interpretation is that the sum of mass of reactants is equal to sum of mass of product plus mass of unreacted reactant. Okay, I will repeat. What does it say? that sum of mass of reactant is equal to sum of mass of product plus mass of unreacted reactant. Okay, we will look at it through the examples. Moving ahead, if you look at its exceptions, that what are the exceptions of law of conservation of mass? The first of all is nuclear reactions. Okay, as in nuclear reaction, what happens? The mass get converted into energy, and hence it does not follow the law of conservation of mass. Okay, so in nuclear reaction there are basically what? Fusion reaction and fission reaction, and in both the reactions energy get produced and the mass is converted into energy, and hence, okay, and hence it does not follow law of conservation of mass. Okay, another example is pair production. Another example is pair production. As you see that there are matter and there are antimatter. Okay, so like if you take electron, then positron is its antimatter. Okay, so now when a photon is basically what? Packet of energy. When photon passes near the nucleus, sometimes it happens that it splits into matter and antimatter. For example, this here is electron and positron. So pair production is one such reaction which does not follow law of conservation of mass. Okay, I hope I am clear to you. Now another example is annihilation reaction. What is annihilation reaction? What is annihilation reaction? In it, the matter and antimatter, they collide and get destructed. Okay, so this destruction after the collision of matter and antimatter is called what? Annihilation reaction. So if electron collides with positron, there is chances that it will lead to annihilation, and it does not follow law of conservation of mass. Okay, I hope I am clear to all of you. Now we are going to write the laws. Okay, the write about the scientist. We'll do some numericals on it also and write the exceptions. Okay, so let us start. I hope you would have written it, so I will erase it. So the first law is what? Law of conservation of mass. Okay, so let us write law of conservation of mass. Okay, so let us write this law was given by Antony Lavoisier. Okay, this law was given by Antony Lavoisier. Okay, according to this law, matter can neither be created nor be destroyed. Okay, now in other words, what do we say? Sum of mass of reactants is equal to sum of mass of products plus mass of unreacted reactants. Okay, for example, if you take calcium carbonate, okay, and it gives calcium oxide plus CO2. Okay, so if this is 100 grams, okay, and this is 56 gram, okay, then what will be its mass? So if it is undergoing 100% reaction, okay, that 100% reactant is being converted into product, then in this case what will happen? If this is 100 gram and this is 56 gram, this will give you what? 44 grams. Okay, I hope I am clear to you. Okay, now consider that you have a reactant A and it is giving you product B plus C. Now, if A is 10 gram and B is 2 gram and C is 3 gram. Now, if they ask you what is the unreacted reactant in this case, so what you are going to do is you will simply apply law of conservation of mass. So here you can see there is, what is the mass of reactant? 10 gram. And what is the mass of product? 2 plus 3 gram, that is 5 gram. So mass of unreacted reactant will be how much? 10 minus 5 gram is equal to 5 gram. So 5 gram is what? It is mass of unreacted reactant. Mass of unreacted reactant. Okay, I hope I am clear to you. So you can note it down. Okay, I hope you would have noted down. Now we are going to talk about the exceptions that we have already discussed. Okay, so let us write the exceptions of this particular law. Okay, so we have already discussed the exceptions. So first of them were what? What was the first exception? Can you tell me? Okay, so the first exception was what? Nuclear reactions. Okay, so you can write down the exceptions. Exceptions. The first one is your what? Nuclear reactions. Nuclear reactions. That is your what? Fission and fusion reaction. Okay, so that is your what? Fission reaction and fusion reaction. Okay, so fission reaction is one of the cases what? Uranium, it splits into barium and krypton and energy. Okay, and fusion is what? Hydrogen to hydrogen atom combined to form helium. Okay, so that is your fusion reaction. In fission, basically what happens? A bigger atom breaks into smaller atoms, and in fusion reaction what happens? What? The two smaller atoms combine to form a bigger atom. Okay, so that is what the meaning of fission and fusion is. Okay, second one is your what? Pair production. Pair production. So we have already discussed about pair production. What is pair production? In this particular case, when photon passes near the nucleus, there are chances that matter and antimatter such as electron and positron will be produced. Okay, now the third example is what? Tell me, what was your third example? One is your pair production and another one was just opposite of it. Okay, opposite of pair production. So what is the opposite of pair production? That is your annihilation reaction. Okay, that is your what? Annihilation reaction. Annihilation. So what is your annihilation? Basically your matter and antimatter combine, they collide with each other and they destroy each other, they annihilate each other. So if electron and positron combine, okay, so they get annihilated. Okay, so when electron and positron they collide with each other, they destroy each other, and that is your what? Annihilation reaction. Okay, so I hope I am clear to all of you and you can note it down. Okay, now we have to do one question. Okay, so I will just remove it and then we'll do one question on law of conservation of mass. Okay, write down. The question is 12 gram of carbon, 12 gram of carbon reacts with 32 gram of oxygen to form CO2. To form CO2. Verify the law of conservation of mass. Verify the law of conservation of mass. Okay, so you can pause it and do it yourself, and you can also write it in the comment section of the YouTube. Okay, so do it. Okay, so let us do it together. Now, carbon reacts with oxygen, so C plus O2, that is your what? CO2. Okay, C plus O2 is giving you CO2. So first of all, whenever you solve a question of chemistry, so if at all there is possibility of any reaction, then kindly write the chemical reaction first. Okay, so that is going to help you a lot. Now, carbon is how much? 12 gram, and oxygen is how much? 32 grams. So what you can easily observe over here is that 1 mole of carbon has 12 grams and 12 gram is given, and 1 mole of oxygen is how much? 32 grams. 16 into 2, that is 32 gram. So 1 mole of CO2 will be also formed. Now what is the mass of 1 mole of CO2? 12 gram of carbon plus 32 gram of dioxygen. So this is your what? 44 grams, right? And here if you add them, how much you will get? Here you will also get 44 grams. So here also it is how much? 44 gram if you add the mass of reactant. Since mass of reactant is equal to mass of product, so it follows law of conservation of mass. Okay, I hope I am clear and you would have got the answer correctly. Okay, so this was our first law, that is our what? Law of conservation of mass. Okay, now the second law is law of definite proportion. Okay, I will erase it and then we will move to our second law, that is a what? Law of definite proportion. Okay, let us write it down. Law of definite proportion. Law of definite proportion. Okay, so as you can see from the title itself, law of definite proportion means something is definite, and what is definite? The proportion is definite. So it simply says that whenever atoms combine to form compound, their ratio by mass is always fixed. Or in other words, you can say that irrespective of the source from which you are obtaining a compound, the ratio of mass of the elements present in it will be always same, will be always fixed. Okay, so this is what? This is our law of definite proportion. Now this law was given by whom? This was given by Joseph Proust. It was given by whom? It was given by Joseph Proust. Okay, now when you talk about the exceptions of this particular law, okay, so it has got many exceptions. Okay, so first of all, the first one is your what? Non-stoichiometric compounds. Non-stoichiometric compounds means what? Like those compounds in which you will see that one of the atom is in terms of fraction, like Fe 0.950. Okay, so it is one of the non-stoichiometric compound. Okay, another one is isotopes. Okay, so if you take H2O and D2O, now literally both of them are hydrogen only, but since they are isotopes, they have different mass and the ratio will not be same. In case of H2O, it will be 1:8. Okay, H2O 2 hydrogen, that is 2 mass, and oxygen, that is 16 grams. So 2:16 becomes what? 1:8. And if you take D2O, so 4 gram and 16 gram, that becomes how much? 1:4. So isotopes also do not follow law of definite proportion. Now if you have forgotten the definition of isotopes, I will tell you that these are atoms of same element which have same atomic number but different mass number. Okay, so atomic number is definitely going to be same if they are atoms of same element. Okay, so the second case is your what? Isotopes. Okay, third case is your alloys. So what are alloys? They are basically homogeneous mixture of metals. So otherwise, since it is a mixture, we already know about the mixture. Okay, so in mixture there is no fixed proportion. Okay, so you can always vary the composition of the metals according to the requirement. So this also, the alloys also do not follow law of definite proportion. The last one is your polymerization reaction. Polymerization reaction also does not follow law of definite proportion. Okay, so when I write it, you will understand it better. Okay, so whatever I've said, let us just write it down. Okay, so write down this law was given by Joseph Proust. This law was given by Joseph Proust. Okay. According to this law, irrespective of source, a compound always contain elements in fixed ratio by mass. For example, if you take H2O, okay, so here the ratio is what? 1:8, 2 grams of hydrogen in 1 mole and 16 gram of oxygen. So 2:16 becomes what? 1:8 when we simplify it. Okay, so irrespective of from where you get H2O, whether you get it from ocean or from river, from pond, from hand pump, whatever be the source, the ratio of mass of hydrogen and oxygen, it is always going to be 1:8. Okay, I hope I am clear to all of you and you would have written it. Okay, now we are going to talk about the exceptions. Okay, let us talk about exceptions. Okay, what are the exceptions? Write it down. Exceptions. Okay, first one is what? Isotopes. Okay, so we have already talked that H2O and D2O. Okay, so here the ratio is what? 1:8, 2 grams of hydrogen and 16 gram of oxygen, that makes what? 1:8. And here 4 gram of D2O, because mass of deuterium is what? 2 grams, so 2 deuterium mix 4 gram, and 4:16, that is how much? 1:4. So it does not follow law of definite proportion, as you can see, right? Now, secondly, non-stoichiometric compounds. Non-stoichiometric compounds. Okay, so I have already told you the example, Fe 0.950. Now it can also be Fe 0.890. Okay, so this is not fixed, that is why it does not follow law of definite proportion. Now how does this happen? This happens when you have multiple oxidation states. So Fe2 plus Fe3 plus both can be here. Now depending upon the proportion of Fe2 plus and Fe3 plus, this coefficient changes. Okay, so non-stoichiometric compounds do not follow law of definite proportion. Okay, third one is your alloys. Okay, so we have already talked, alloys are basically what? Homogeneous mixture of metals. So anyway it is mixture, so it should not follow the law of definite proportion, that is quite genuine. Okay, now the after that, what do we say? Polymerization reaction. Polymerization reaction. Okay, so in polymerization reaction you can take as many number of monomers you want. So if you take ethene, okay, CH2 double bond CH2, you take an ethene, okay, in high temperature and pressure, okay, and you take catalyst. So depending on how many monomers you take, the polymer will be formed. So again, you can vary n over here. That is why it does not follow law of definite proportion. Okay, I hope I am clear to all of you. So you can just note it down. Okay, now we are going to do one question on it. Okay, let's do one question. Write it down. In a compound, hydrogen and oxygen are present in the ratio 1:8 by mass. Okay, if 9 gram of compound is formed, if 9 gram of compound is formed, find the mass of hydrogen. Find the mass of hydrogen. Okay, so do it and write your answer in comment section. Okay, so that there can be no cheating. Okay, after I solve it and then you will say that my answer was also what I got. Okay, so it is better to be honest. Write your answer in the comment section so that I can see that whether you were able to solve the problem correctly or not. Okay, so please do it. Okay, now let us do it together. First of all, understand the question. Okay, it is very important to understand the question and then you can easily proceed to the answer. Okay, so what is the question saying? It is saying that in a compound, hydrogen and oxygen are present in the ratio 1:8 by mass. That means what? If you combine this becomes what? 9 gram. Okay, or 9 parts. That means what? In 9 parts of the compound, hydrogen is what? 1 part. In 9 part, you have got 1 part of hydrogen. Now the question says, if 9 gram of compound is formed, find the mass of hydrogen. Now this is very easy. Why? Because it is already saying that. The question is telling you what? In implied sense, that in 9 parts of the compound, 1 part of hydrogen is present. And now here they have exactly given you what? 9 gram of compound. That means what? How many gram of hydrogen will be present? It is very easy. You don't even need pen and paper. You can easily say that what? It will be how much? 1 gram of hydrogen will be present in the compound. Okay, since in 9 part 1 part of hydrogen is present, so that is why in 9 gram 1 gram of hydrogen will be present. Okay, so you can simply write down, in 9 parts of compound, 1 part of hydrogen was present. So in 9 gram of compound, 1 gram of hydrogen will be present. So this 1 gram becomes your answer. Okay. I hope all of you would have got it correctly. Now we are going to move to the third law of chemical combination. Okay. So that is your what? This was your definite proportion. Now we will move to law of multiple proportion. Okay. Now we are going to move to the law of multiple proportion. So let us write it down. Law of multiple proportion. Law of multiple proportion. So now listen to me first of all. So this law was given by Dalton. This law was given what? Dalton. Now in this particular case, what you see that when you use two elements to form compounds, to form two or more than two compounds, then in that case, that element which reacts with fixed mass of other element, okay, is in simple whole number ratio, is in simple whole number ratio. For example, okay, first look at the example. Okay, so let us consider this reaction between hydrogen and oxygen. Okay, so hydrogen and oxygen react to form what? Hydrogen peroxide. Okay, now this hydrogen also reacts with oxygen to form what? Water. Now whenever you write the reaction, make sure that you check that whether the reaction is balanced or not. So here two hydrogen is on reactant side, two hydrogen is on product side, hydrogen is balanced. Here two oxygen is on reactant side and two oxygen is on product side. So here oxygen is also balanced. So first reaction is completely balanced. If you look at the second reaction, again here 4 hydrogen is there, here in product side also 4 hydrogen is there, in reactant side 2 oxygen is there, and here also 2 oxygen is there. So our reaction is completely balanced. Okay, now if you take 1 mole of dihydrogen, it is how much? 2 grams, and 1 mole of dioxygen, it is how much? 32 grams. 16 into 2, 32 gram. Here it is how much? 4 gram, and this is how much? 32 grams. Okay, now here you can see that the mass of oxygen in both the reaction remains same, okay, for 1 mole, but the hydrogen in both the cases, mass of hydrogen in both the cases is varying. And what will be the ratio over here? It will be what? 2:4. That is how much? 1:2. So this is your what? Simple whole number ratio. That is all the reaction says, that the mass of the reactant which reacts with fixed mass of other element, okay, is in simple whole number ratio. So here the mass of hydrogen is varying and it is reacting with fixed mass of dioxygen. So here we can see that the ratio of mass of dihydrogen in both the cases are in simple whole number ratio. Okay, so you can note down this example. Okay, after that we are going to write what this law says. Okay. Okay, I hope you would have written. Moving ahead, let us write a little bit about this particular law. So this law was given by Dalton. This law was given by Dalton. Correct? Write down what this says. Okay. According to this law, according to this law, the mass of the element which reacts with which reacts with fixed mass of other element is in simple whole number ratio. Okay. Now this also has exception. Okay. What is the exception? Its exception are non-stoichiometric compounds. Non-stoichiometric compounds. Okay. For example, again, Fe 0.950 and Fe 0.890. So this cannot be considered in simple whole number ratio. Okay. So law of multiple proportion has its exception as non-stoichiometric compounds. Okay. So you can write it down. Okay. Now we'll again do one question on it, on law of multiple proportion. Okay, let us do a question. Write down. Nitrogen and oxygen. Nitrogen and oxygen form two oxides. Form two oxides. In one oxide, 14 gram nitrogen reacts with 16 gram oxygen. In another 14 gram nitrogen reacts with 32 gram oxygen. So this follows a law. Okay, so please try to solve it yourself, and you can also take the pic and paste it in comment section if possible. Okay, so try to solve it yourself, pause it and try to solve it yourself first. Okay, now let us look at it. What does the question say? The question says that nitrogen and oxygen form two oxides. Okay, one oxide has 14 gram nitrogen and it reacts with 16 gram of oxygen. Another 14 gram reacts with 32. So let us make a table. This is your nitrogen, oxygen and oxide. Okay, so in both the cases nitrogen is how much? 14 gram. So you write 14 gram, 14 gram. Okay, now oxygen, another, here it is 16 gram. In first case it is 16 gram and in second case it is how much? 32 gram. Okay, so you can see this nitrogen, mass of nitrogen is remaining same in both the cases. What is varying is oxygen, to which we have to pay attention. Now it is in ratio of what? 1:2, and this is what? Simple whole number ratio. So this follows what? Law of multiple proportion. Okay, I hope I am clear to all of you and you would have been able to solve it too. Okay, now moving ahead, we have to read about two easy law of our combination. Okay, law of chemical combination, two easy laws we have to study now. Okay, so next one is your what? Next one is your Gay-Lussac's law. Okay, next one is your what? Gay-Lussac's law. Gay-Lussac's law. Okay, so the name itself tells you that this law was given by Gay-Lussac. Okay, now what does it say? This is a very simple law which says that whenever gases react with each other or gases are produced in a reaction, it does so in simple whole number ratio, as simple as that. Okay, it simply means that when two reacts combine, they combine in simple whole number ratio. That's it. Okay, so let us write it down. Okay, it is as simple as that. Okay, so this law was given by Lussac. Okay, now according to this law, when gases react or are produced in a chemical reaction or are produced in a chemical reaction, they do so in simple whole number ratio. Okay, for example, N2 plus 3H2 gives you what? 2NH3. So here you can see what? It N2 and H2 are gases, they are reacting in what? 1:3 ratio, which is what? Simple whole number. That is why it follows your what? Gay-Lussac's law. Okay, so you can note it down. Okay, so I hope you would have written it. Okay, now we are moving to next simple law of chemical combination, that is your what? Avogadro's law. Okay, that is your what? Avogadro's law. Okay, so let us move to the next one, right? Avogadro's law. Okay, Avogadro's law. Okay, so as the name suggests, this law was given by Avogadro. Now what does it say? That at same temperature and pressure, okay, gases having same volume contain same number of molecules. Okay, it simply says that if you have two gases and they are at same temperature and pressure and their volume is also same, in that particular case they will also contain the same number of molecules. Okay, so it is very simple. Let us write it down. Okay, and we'll also explain it with the help of example. This law was given by Avogadro. Okay, this law was given by Avogadro. According to this law, at same temperature and pressure, gases having same volume contain same number of molecules. Okay, so for example, if you take 100 ml of N2 and 100 ml of O2 at suppose 27 degrees Celsius and 1 atm pressure, then what will happen? Both of them, since they have same volume, they will contain same number of molecules. Okay, now you will exactly come to know that how many molecules it contains when we talk about the same concept in mole concept in our next class. Okay, so please do watch our next class also. Okay, so I hope you have got this and you can note it down. Okay, now we have reached our last law, that is law of reciprocal proportion. Okay, now we are going to talk about what? We are going to talk about law of reciprocal proportion. Okay, let us write down law of reciprocal proportion. Okay, now this law was given by Jeremy Richer. Okay, so write it down. This law was given by Jeremy Richer. Okay, now we will understand this particular law with the help of example. First we'll look at the example and then we will understand. Okay, now suppose that you have a element carbon which reacts with oxygen C plus O2 gives you how what? CO2. This carbon also reacts with hydrogen C plus H2, 2H2 gives you what? CH4. Okay, let us see if this reaction is balanced or not. So one carbon on reactant side, one carbon on product side, two oxygen on reactant side, two oxygen on product side. So first reaction is balanced. Okay, next one carbon on reactant side, one carbon on product side, four hydrogen on reactant side, four hydrogen on product side. So both the reaction are balanced. Okay, so if you take 1 mole, this is 12 gram, this is how much? 32 gram. Okay, here if you look at it, this is how much? 12 gram, and this is how much? 4 gram. Right, now if you look at those reactants which are changing, carbon is same in both. What is changing? Oxygen and hydrogen. And if you take their ratio, so ratio of hydrogen to oxygen will be what? 4:32. That is nothing but your what? 1:8. Okay, now let us react those reactants which are not same in both the reaction. So you react hydrogen with oxygen, so it gives you what? 2H2O. Now look at the ratio over here. This is how much? 32 gram, and this is how much? 4 gram. So again the ratio becomes what? 1:8, and it is same over here. This is exactly the law of reciprocal proportion says. It says that when two elements react with a particular element, then the ratio in which they react with that particular element is same or multiple of it when they react with each other. Okay, I hope I am clear to you. So you can just note down this example, and then we'll move to the definition part. Okay, so write down when two elements react with fixed third element, then the ratio in which they react with it is either same or multiple of it when they react with each other. Okay, I hope you have written it. Okay, now again, if you talk about its exception, okay, again, non-stoichiometric compounds are also its exception. Non-stoichiometric compounds. Okay, so please note it down. Okay, so this was all about our law of chemical combination. Okay, now we are going to take up another very small topic, that is your what? Dalton's atomic theory. Okay, we are going to take up another very small topic, that is what? Our Dalton's atomic theory. Okay, let us quickly put this headline: Dalton's atomic theory. Okay, now let us look at what this theory says. Okay, so the first point of Dalton's atomic theory is what? Matter is composed of indivisible particles called atoms. Okay, now again, so there are certain examples in which what? Now it is uh, commonly known that atom is composed of electron, proton and neutron, and you can definitely break a atom, and that is how you get charged ions and all. Okay, so now we have already said that what? Atom is, and matter is composed of what? Indivisible particles called atoms, and it has been disproved by the discovery of electron, proton and neutron. The second point says that the atoms of same element are same in properties and in mass. Okay, this has also been disproved by isotopes, because we know that isotopes are what? They are atoms of same element but they have different mass. Okay, thirdly, it says that atoms combine in fixed ratio to form compounds. Okay, so but again we have seen non-stoichiometric compounds. Here the ratio is varying because of the different oxidation states and the amount of it present in those particular compound. Okay, and lastly it says that atoms can neither be created nor be destroyed in a particular reaction, only its reorganization takes place. Now in nuclear reaction we know that atoms are also created and destroyed, so new type of atoms are produced, as you can see in fission reaction, that when uranium breaks, it breaks into what? Barium and krypton. So here barium and krypton are, they are basically atoms of different element. Okay, so let us write the Dalton's atomic theory. Okay, so first one is what? Matter is made up of indivisible particles called atoms. Okay, secondly, atoms of same element atoms of same element are same in properties and mass. Okay, third one is what? Atoms combine in fixed ratio to form compounds. Okay, lastly, atoms can neither be created nor be destroyed in a chemical reaction. Only their reorganization takes place. Okay, so you can note it down. Okay, now what we are going to do is we are going to do a question from JEE Mains. It is a previous year question. Okay, so let us remove it and then we are going to do a question. Okay, write down the question. Among the following statements, that which was not proposed by Dalton was. This was asked in JEE Mains 2020. Okay, so people who are preparing for NEET should also do this because not much difference is there is now in standard of JEE Mains and NEET. So all of you do it, whether you are preparing for JEE or you are preparing for NEET or you are preparing for CUET. Okay, it doesn't matter which exam you are preparing for, all of you have to do this question, and this question is actually very easy. Okay, write down all the atoms of a given element have identical properties including identical mass. Atoms of different elements differ in mass. This is your first option. Okay, second is matter consists of indivisible atoms. Okay, your third option is chemical reactions involve reorganization of atoms. These are neither created nor destroyed in a chemical reaction. Nor destroyed in a chemical reaction. Okay, the last one is when gases combine or reproduced in a chemical reaction, they do so in a simple ratio by volume, provided all gases are at same temperature and pressure. Okay, now do it and write your answer in comment section. No cheating. Okay, write your answer in comment section. Okay, let us do it. So this is asking which was not proposed. Okay, so please remember this not. Because of this not, many of you do very silly mistakes. Okay, now look at the options. All the atoms of a given element have identical properties including identical mass. Atoms of elements differ in mass. Okay, this was the particular it was given by the Dalton in his particular theory. Okay, so this is one of the theories. Okay, second, matter consists of indivisible atom. This is also correct. It was also in his theory. Chemical reactions involve reorganization of atom. These are neither created nor destroyed in a chemical reaction. Just now we have studied. Okay, so this is also present in the theory of Dalton. And lastly, when gases combine or reproduce in a chemical reaction, they do not do so. They do so in a simple ratio by volume, provided all gases are at same temperature and pressure. So this was not present in Dalton's atomic theory. So the fourth option will become your answer. Okay, so I hope this is clear to all of you. You would have understood the laws of chemical combination and Dalton's atomic theory properly. Okay, so at the end, let us quickly revise it. So what did we basically read? We have studied laws of chemical combination. The first one was your what? Law of conservation of mass. It says that what? Sum of mass of reactant is equal to sum of mass of product plus mass of unreacted reactant. Then we had studied law of definite proportion. It says that irrespective of the source, okay, a compound always contain elements in fixed ratio by mass. Then we had law of multiple proportion. What does it say? That the mass of reactant which reacts with fixed mass of other reactant is in simple whole number ratio. Then we had what? Gay-Lussac's law. What Gay-Lussac's law says? That whenever gases react or are produced in a reaction, they do so in simple whole number ratio. Okay, and then we had Avogadro's law. What does Avogadro law say? That at same temperature and pressure, if gases have same volume, they will have same number of molecules. This was our what? Avogadro's law. And lastly, we studied about law of reciprocal proportion. What did it say? That when two elements combine with a fixed third element, then the ratio in which they combined with the third element are either same or are multiple of it when they react with each other. This was your what? Law of reciprocal proportion. And after that we studied Dalton's atomic theory, which simply says that what? Matters are composed of indivisible particles called atoms. Atoms of same element are same in property and mass. Thirdly, atoms combine in fixed ratio to form compounds. And lastly, atoms are neither created nor destroyed in a chemical reaction. They just get rearranged. So it was all about our today's class. We'll meet again in next class. Till then, take care and thanks a lot.